experimental observation. Thus, a large amount of bromine can be present in water as hydrogen bromide. But how can we convert bromine to hydrogen bromide? In HBr, the oxidation state of bromine is -1. The Br2, therefore, must undergo reduction. Here is the half reaction. Sulfur dioxide has been found to be the most economical reducing agent. Here are both half reactions. We add them to obtain the equation for the overall reaction. Then, adding the appropriate E0 values gives a positive figure showing that the overall reaction may occur. Note that an aqueous solution of hydrogen bromide will be produced. Therefore, the gaseous bromine, when blown out of the seawater, can be concentrated as aqueous hydrogen bromide. We have modified the apparatus to attempt the reduction of bromine with sulfur dioxide. The compressed air is again turned on, and elemental bromine is blown out. The sulfur dioxide is added through this tube and mixes with the bromine and water vapor coming down the column. The bromine color disappears, and colorless hydrogen bromide gas is formed, which passes into the water in this receiver. After a few minutes, the seawater solution loses its color, showing that the bromine has been blown out. Because of its high solubility, the hydrogen bromide which was formed should have collected in the water in this receiving flask. To check this, we again use chlorine to oxidize the hydrogen bromide in the receiving flask. The characteristic color of aqueous bromine appears. The bromide ions in the hydrogen bromide solution are oxidized by chlorine to produce elemental bromine. Thus, we have succeeded in concentrating the bromine from the seawater in a much smaller volume of solution. Since our goal is to obtain elemental bromine, how do we now remove the bromine from the water in which it is dissolved? We could blow it out with air, as we did before, but to minimize loss of bromine into the air, we'll use live steam produced in this flask. The steam condenses as it passes into the solution, raising the temperature. Because bromine is more volatile than water, it distills from the solution. Relatively pure bromine condenses and collects in this receiving flask. On a laboratory scale, we have succeeded in obtaining this small quantity of bromine, less than 1 gram, from this large volume of seawater. Over 100 million pounds of bromine are extracted from seawater every year on an industrial scale. At the Ethel Dow Company's plant at Freeport, Texas, the seawater enters through a deep water intake channel. The water flows past screens which remove small marine life and debris. Now, recall our laboratory procedures as we look at the industrial process for extracting bromine. In this large green pipe, the filtered water is acidified with sulfuric acid. Near the top of the pipe, chlorine is added to accomplish oxidation of the bromine. The chlorinated water is then divided into many small streams. From here, the water falls as spray through this brick tower, as huge quantities of air are forced in at the bottom of the structure to blow out the bromine vapor. The air and bromine vapor leave through this large green pipe. The small white pipe introduces sulfur dioxide gas to reduce the bromine vapor. The hydrogen bromide which is formed is concentrated in this absorption tank by dissolving in a falling spray of water. The concentrated hydrogen bromide solution then enters this tower, and chlorine is added to reoxidize the bromide. Steam is used to distill bromine from the solution. The bromine is then condensed to a liquid which can be stored for later use. Thus, the industrial process of extracting bromine from seawater follows our laboratory chemistry. Starting with acidified seawater, chlorine is added to oxidize the bromide ions. This yields a dilute aqueous bromine solution. Air blows out the bromine, and sulfur dioxide gas in the presence of water reduces the bromine to bromide. Highly soluble hydrogen bromide gas is formed and absorbed in water. In the final step, chlorine gas is used once more to oxidize the bromide ions. The bromine is then removed by steam, giving us the element bromine.